Write it fast, children, because we have to even start the lesson also. We were in continuation with the lesson, atoms and molecules.
Question, ma'am. A, B, C, D.
Sorry. No,
Ma'am,
it's the question. Question is 12th one. Write the steps you would use for making tea. Use the words solution, solvent, solute, dissolve, soluble, insoluble, filtrate, and residue. So you have to use these words and you have to write the steps how you'll prepare. It's the answer itself, it's not the question. And here is the 13th question. This is the 12th one. These are the steps, ma. Don't get confused. First step is A. These are the steps A, B, C, D. Okay. Yes, we finished 12th one.
No, ma'am, we are
No, ma'am.
writing.
Yeah, ma'am, completed.
Yes, ma'am. Shall I scroll down?
Completed 12th.
Completed?
Yeah, ma'am.
No, no, ma'am.
Girls?
Ma'am, last point. Yeah, ma'am.
Okay. Shall I scroll a little bit up? You can see it now?
Yes, ma'am.
Okay. Write this 13th
Question
one
also, ma'am.
fast. No need. Leave the space for question. You can write it. If you have the textbook, you can write the question later on. Write the answer, and then we'll continue with the next lesson. Then tomorrow I'll just show you. I'll give you time to write down the notes. Okay?
Ma'am, that table is question or answer?
Answer. Just one second. I'll just check it.
It is answer, ma'am.
No.
Down.
Just one second. Yeah, it's answer. Yeah. Sorry. You can write this question later on. 13th question you can write. Leave some space and write it afterwards, children. Question. Okay?
Ma'am, we have to write question.
No, ma'am, don't write the question now. Write it later on.
Okay.
Leave the space and write the question afterwards.
Okay.
If you have finished 12th one, should I scroll up?
Yeah, ma'am.
No,
Finished.
ma'am.
Finished? Twelfth answer is finished.
1 minute.
You can write this answer on your own also. 12th one especially. You must have an idea of that. That's it. Okay?
Completed, ma'am.
13th answer, I'm showing it to you. Yeah, you can see it. Okay. So we were discussing about the atoms and molecules. So scientist Anthony Laurent Lavoisier, he was the first French nobleman and a chemist who has established the two important laws. The two important laws are the chemical combination, laws of chemical combinations, which are law of conservation of mass and law of constant proportions. So these are the two laws who was being given by the scientist Lavoisier. So he is also called as the father of modern chemistry. Okay. And now talking about the atoms and molecules, children. So if we talk about the atom, we know that atom is very minute, isn't it? It is very small. So even though it is very small, the atom contains electrons, protons, and neutrons. We know that, but we will not call them as, we will not combine it. We will not include these electrons and protons and neutrons when we are talking about atom, when we are talking about mass of an atom, when we are writing the mass or when we are defining an atom of like hydrogen atom or copper or silicon, will not consider, will not talk about the electrons, protons, and neutrons when we are talking about their mass. So the elements like hydrogen and oxygen. For example, I'm talking. I'll just share the screen with you. Just 1 second. I'll stop this here. Just give me 1 second. So if we just talk about hydrogen atom, so we write it like on 10 minutes left. H. We write it like H2O, isn't it, children? We write it like H2O. In this hydrogen atom, we call it as hydrogen atom and oxygen atom. So the smallest particle, the smallest entity of the element, which has same properties like the element, like if we call about, we talk about the sodium. Sodium, we just tell, like we write it like Na. So this is a sodium molecule. If we consider the sodium atom, all the small atoms combine together to form one sodium molecule, one sodium atom. So these small atoms, when they combine together, they form the mass of that atom. They form the mass of that particular atom. If we talk about this hydrogen and oxygen, when the hydrogen we write it as H2O. Now what is this? Why we are writing like this? Why we are defining this proportion? So in a chemical substance, the elements are always present in definite proportions by mass. Like we are writing H2O. So the mass of hydrogen is 2. So now atomic number is also there. We are writing, what is the atomic number of oxygen, children? And what is the atomic number of hydrogen
Ma'am, hydrogen is 1, ma'am.
and oxygen?
Ma'am, I think 16.
Yes, ma'am.
Yes, it is 16. So here hydrogen atomic number is 1 and then oxygen is 16. Then you, ma'am, why you are writing this H2O? Why we write, here we are taking two hydrogen molecules and one oxygen is combining to form water molecule. Two hydrogen atoms and one oxygen atom is combining together to form H2O, which we call it as a molecule, water molecule, isn't it, children? Now, if we take two hydrogen atoms and two oxygen atoms, then what will happen? The complete chemical compound will change, isn't it? What it will become if we just write down H2O2. Ma'am, I just want to take two hydrogen atom and two oxygen atom. Now, what will happen? H2 and O2, if you just want to take two oxygen molecules you want to take, then what will become, what will happen? Its complete chemical compound will change, isn't it? What is it called now? What is the name of this? it is called as? Yes, hydrogen peroxide. The complete chemical compound will change now. So the compounds with basic proportions, if they are in equal proportion by mass, they will not change. In a chemical substance, the elements are always present in definite proportion by its mass. Then it is called as the the law which is proposed by Lavoisier. It is called as the law of constant proportion. He proposed the law of constant proportion. He told that in a chemical substance, the elements are always present in definite proportion by mass. We are taking two hydrogen atoms and one oxygen. We are taking in this proportion only. So a molecule of water will be in same proportion. Otherwise, the compound will change. Did you understand, children? Have you understood?
Yes, ma'am. Yeah, ma'am.
Okay. Now, if we talk about the law of conservation of mass, the law was given by Lavoisier. The two laws were proposed by Lavoisier. What are those two laws?
Ma'am, law
Law
of
of
mass and law of constant proportions.
Yes, so law of constant proportion was also given by him. Now talking about law of conservation of mass. Mass can neither be created nor destroyed in a chemical reaction. So when a chemical reaction is taking place, children, what happens? The mass can neither be created nor destroyed. Only the energy is being released in a it will get the product with same amount. Like for example, if we see this, we are taking 1 kg of, just 1 second, I'll give you one example. A, molecule of A, assuming like A, 1 kg A, reactants we are taking, reactants, two reactants, and we are just combining them together. B of, 2 kg, we are taking A of mass 1 kg, and we are taking one product of B 2 kg, and we are combining them together. And what we are getting here? We are getting a resultant product as C. C is of, now we are combining together to get 3 kg. When we are combining 2 and 3, we'll get the product C as 3 kg. So the mass will not change. Mass can neither be created nor destroyed in a chemical reaction. When we are combining two chemicals, when a reaction is taking place in between two, then the resultant will not lose anything, will not lose the mass. Mass will be same. Mass will be combined when we are combining two chemicals and we are conducting a chemical reaction. When we are combining two chemicals, the reaction will take place, but will not lose anything until and unless it happens only in the case of fission reaction, nuclear fission reaction. What happens in a nuclear fission reaction? Will lose the energy will be lost, isn't it? And will not get the same mass. Yes, are you there?
Yes, ma'am.
What happens in a nuclear fission reaction?
Ma'am,
The mass will not be same. Mass will not be same, and will lose lots and lots of amount of energy. But here in the case of a chemical reaction, the chemicals, if we are combining two chemicals, then the resultant product which we are getting will not change. There will not be any change. So this is about the law of conservation of mass. It states that mass can neither be created nor destroyed in a chemical reaction. Nuclear fission and nuclear fusion reactions, those are not the chemical reactions. Those are the fission reactions in which we are colliding. The molecules will collide with each other, and lots of energy is being released in it. And products will not be remain same. And if we talk about the law of constant proportion, I want you all to note down these two laws. I'll share the slide with you. I want you to write down these two laws. Yes, I think you have noted down about this
Yes, ma'am.
law of conservation of mass. Yes, write down this also. The law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Please write it down, children.
Completed, ma'am.
So when we are talking about the mass of a particular molecule or mass of a particular compound, then we will not consider the protons, how many electrons are there, how many neutrons are there. We cannot decide based on the positivity or negativity of that particular element. So the mass totally depends on the nature of the compound totally depends on the mass and its nature. The pure substance, depending on this, the elements and compounds are divided into elements and compounds. If we talk about elements, elements are the pure substances. If you just complete writing this, I want you to write down the law of constant proportion also.
Ma'am, time up, ma'am. Time up, ma'am.
Okay, we'll continue tomorrow then. Even
Yeah,
you
Okay,
ma'am.
ma'am.
have next
Okay,
class also,
thank
no?
you.
Okay, ma'am.